Alright, so in this particular video, I'm going to start out with the geologic timescale that I ended in the last video with. And if you look on this video, you can see the age of the Earth is 4.6 billion years. And you got to go a really long time. So all this spinning around here on the bottom, all the way to right here, that 545 million, that's all Precambrian, 87% of geologic time. This is when life is believed to have exploded. And so this is the beginning of the Phanerozoic eon. So it only goes from there to there. That's all the Phanerozoic is. So it's 13% of geologic time. And we go along on, this is all in the Paleozoic until you get to about right here. So this here would be the when Pangaea is believed to have broken, the Paleozoic era ends, and we go into the Mesozoic era, which is the age of reptiles, and you can see where we have our dinosaurs. And the Mesozoic is broken down to the Triassic and the Jurassic and the Cretaceous. And then when we get to about right here, this is when we believe the meteorite struck and led to the extinction of dinosaurs. The Mesozoic ended and the Cenozoic began. And so we've been in the Cenozoic all this time. And as you can see, here's man right here. Alright, so pretty recent. Kind of just to point out here, horses are believed to have been around for 5 million years, so a lot longer than humans, just to point. And so just a couple of people that contributed to the geological timescale. So Nicholas Steno with the law of original horizontality and the law of superposition, and James Hutton and Charles Lyell came up with the law of uniformitarianism, and William Strata Smith, who came up with the principle. So the geological timescale is first broken into eons, and eons are the largest expanse of time, and eons are broken down into eras, and eras are broken down into epochs, and epochs are broken down into, periods, and periods are broken down into epochs. So eons are the largest amount of time, and epochs are the smallest amount of time. So we had the Phanerozoic eon here, which is broken down into these three eras, and then eras are broken down into periods, and periods are broken down into epochs. You can't see it on this little graphic, is not well. Here would be a really good geological timescale. So a couple of things I want to point out here. Collectively, 87% of the geological timescale is the Precambrian, and that all ends right here. The only life forms that we would have had would have been some single-celled organisms. And 543 million years ago, that's when life exploded. So that's when the Phanerozoic began. The Phanerozoic is broken down into the Cenozoic and the Mesozoic and the Paleozoic. So right here. So the Precambrian is here, and as you can see, it's called the Precambrian because this is the Cambrian period. So the Cambrian period, and so all the time before this Cambrian period is called the Precambrian. All right. As you can see, the Paleozoic is broken down into periods. You don't need to memorize these periods. The Mesozoic is broken down into periods. You don't need to memorize those. And the Cenozoic is broken down into periods. You don't need to memorize those. And periods are broken down into epochs. Now, it's only the Cenozoic era that got epochs because you're talking some really fine detail. Rocks that are older than the Cenozoic, it would be tough to kind of tell the difference between epochs. So we only have epochs for the Cenozoic. I'd like to point out this Pleistocene here, this is the Ice Age. The end of the Ice Age was right here, and then we got into the Eocene epoch. So that's the epoch that we've been in since the last Ice Age. So single-celled organisms down here in the Precambrian. Then we have invertebrates, and we have the age of invertebrates, the age of fish, and the age of amphibians, all in the Paleozoic. Age of reptiles is in the Mesozoic, and the age of mammals is in the Cenozoic. So that's a little brief synopsis of the geological timescale. Remember, there was a big extinction of trilobites here and other marine species due to the breakup of Pangaea, we think. And also there was another one right here at around 65, 66 million due to the meteorite impact that led to the extinction of dinosaurs and other species. And you're going to need to know that. I already talked about the Phanerozoic, the visible life, began around 540 million years ago. These are just three segments of geologic time that the Precambrian is broken down into. You will not need to know these for the course. And in terms of eons are broken down into eras. So the first era was the Paleozoic, which stands for ancient life, and Mesozoic for middle life, and Cenozoic for recent life. And then those eras are broken down into epochs, and epochs are broken down into, periods, and periods are broken down into epochs. So the Precambrian basically existed from 4.54 billion years ago right up to only 545 million years ago. It's the greatest expanse of Earth's history. It's not really divided into smaller time units like periods and epochs just because we know so little about it. Most of the rocks are either weathered and eroded away, they don't exist anymore, they're just so old, they lack fossils, mostly because the chemical and the physical conditions of Earth at that time couldn't support couldn't support life. Maybe, you know, extreme UV levels, extreme temperatures, it just, you know, the oxygen in the atmosphere just wasn't good enough. So really the first abundant fossils started to appear after the Precambrian is done. So once we got into the Cambrian period of the Paleozoic. Here is another geological time scale. I'm not going to explain it because it's just like the one I previously explained. I mean, you can see your ages, you can see your epochs, you can see your periods, you can see your eras, you can see your eons, and you can see the Precambrian. You can also see over here when the two extinctions, and you can also see the evolution of life over there. There was two big mass extinctions. And unfortunately, I wish they would have broken them down into eras. For example, like if we would have said we have an extinction at the end of the Paleozoic and the beginning of the Mesozoic. And that's when trilobites went extinct, and that's when, and possibly due to the breakup of Pangaea. But what they did was they took the last period in the Paleozoic and the first period in the Mesozoic, so it's actually the Permian-Triassic extinction. Similarly, they didn't say the Mesozoic-Cenozoic extinction, or boundary. They said the last period, Cretaceous, in the Mesozoic, and the first period in the Cenozoic, which is Tertiary. And this is basically the extinction of dinosaurs due to the meteor. The most widely accepted hypothesis for the extinction at the end of the Paleozoic is the breakup of Pangaea and the associated loss of habitat. This is a really important thing because everybody just talks about trilobites. This was about 248 million years ago, and 96% of all marine species completely disappeared. Trilobites were just one example. The other one was at the end of the Mesozoic era, and we think this is due to the meteorite that actually struck the Earth and probably changed climate and that kind of thing. It ended the dinosaurs, which were the largest reptiles. But this was about 65 million years ago, and over 50% of all species on the planet possibly went into extinction. Other explanations for these two mass extinctions, besides meteorite impact and supercontinent breakup, could have been falls in sea level, could have been climate changes, could have been prolonged volcanic eruptions, could have been periods of lack of oxygen in oceans. These are all possible explanations, which you don't really need to know. You just need to know the two extinctions based on their period names.